Hello all, so let us see some more problems in today's class on absolute maximum, on applied maximum and minimum. So the question is, a closed cylindrical can is to hold 1 liter, that is 1000 centimeter cube of liquid. How should we choose the height and radius to minimize the amount of material required to manufacture the can? So the can must hold 1000 centimeter cube of liquid. Then we need to find height and radius such that the amount of material required is minimum. So that means we have to minimize the surface area of the can subject to the condition. So you are given the volume must be equal to 1000 centimeter cube. Now for the surface area and volume of can, so we need, so it's a cylinder, so for cylinder you have two variables, the height and the radius. So let us take, so let h be the height of the can and r be the radius of the can. So these are all in centimeters, so it's the radius of the can, and let S denote the surface area and V is the volume. So we need to minimize now. Our aim is to minimize the surface area such that volume is equal to 1000 centimeter cube. Now we are having a closed cylindrical can. അപ്പോൾ മുകളിലത്തെ cylindrical portion included ആണ്, താഴത്തെ cylindrical portion included ആണ്. Then you have this cylindrical part of the surface. So therefore the surface area will be area of the top and bottom part, that will be bottom part, that will be pi r square. So you will get 2 pi r square, and the area of this portion will be 2 pi r h. So we need to minimize S such that, so volume is pi r square h, so pi r square h is equal to 1000. Now if pi r square h is equal to 1000, ഇനി നമുക്ക് s എന്ന് പറയുന്നത് 2 വേരിയബിൾ ആണ്. അപ്പോൾ നമുക്ക് ഈ കണ്ടീഷൻ ഉപയോഗിച്ച് അതിനെ സിംഗിൾ വേരിയബിളിലേക്ക് കൺവേർട്ട് ചെയ്യാൻ പറ്റും. സോ ഹിയർ h will be 1000 by pi r square. So let us substitute h here. So therefore to minimize, so s becomes 2 pi r square plus 2 pi r, so h is 1000 by pi r square. So that implies s will be equal to 2 pi r square plus, you will get 2000, pi will cancel off, r will cancel off, 2000 by r. Now here you have r such that r belongs to the interval 0 to plus infinity. R എന്ന് പറയുന്ന radius ആണ്. Radius cannot be 0. Okay. So because you cannot have a cylindrical can with radius 0. So R belongs to the interval 0 to infinity. So this is like finding the maximum and minimum in an infinite interval. So when you take the limit, so limit R tends to 0 plus 2 pi r square plus 2000 by r, that will be equal to, first term 0 ohm, second term 2000 by 0, that will be plus infinity, and again limit r tends to infinity minus, so that will be 2 pi r square plus 2000 by r. So 2000 by r and the limit to 0 ohm, this will be again plus infinity. So there is only absolute minimum in this interval. There is no absolute max, so there is only absolute minimum in the interval. So that will occur at the critical point. So which occurs at the critical point. So let us find the critical point. So for that, take ds by dr. So ds by dr is equal to 4 pi r minus 2000 by r square. So that gives, so you will get 4 pi r cube minus 2000 by r square. So therefore ds by dr equal to 0 implies, so you will have 4 pi r cube minus 2000. This will be equal to 0, so r cube will be equal to 2000 by 4 pi. So that is 500 by pi. So r is equal to 500 by pi whole raised to 1 by 3. So this is approximately equal to 5.4. Now when you calculate d square s by dr square, that will be equal to, so you will get 4 pi plus 2000 by into 2 by r cube. So therefore this is greater than 0. So therefore r equal to 5.4 is a minimum. So therefore the radius, the required radius is 5.4 and the height will be equal to, so namukku vendiya height ennu parayna, that is 100 by pi r square. So that will be 100 by pi, sorry, 1000 by pi r square aayirukku veda. So 5.4 whole square. So that is the value of height and radius we have to choose for the can. So simplify the value of height. So that's the value of radius and height. So the second question is, find the point on the curve y equal to x square that is closest to the point 18, 0. So you are given the curve y equal to x square and a point 18, 0 is given. But from 18, 0 you need to find a point on the curve y equal to x square such that the distance between those two points is minimum. Let us take, so let us start with a point on the curve y equal to x square. So let xy be an arbitrary point on the curve y equal to x square. Then the distance between 18, 0 and xy is, so that is L equal to root of x minus 18 whole square plus y square. Now we need to minimize L, and minimizing L and the value of xy for which, for the value of xy for which L square is L is a minimum, L square is also a minimum. അപ്പോൾ നമ്മുടെ aim എന്ന് പറയുന്നത് L minimize ചെയ്യാനാണ്. So here you have a square root. Now in order to avoid the square root, നമുക്ക് differentiate ചെയ്യുമ്പോൾ കുറച്ച് difficult ആയിരിക്കും square root ഉണ്ടെങ്കിൽ. So I am converting the problem as to minimize L square. അപ്പോൾ നമുക്ക് L square minimum value കിട്ടും. When you take the square root, that will give you the minimum value for L also. So let us take, so let S is equal to L square, so that is equal to x minus 18 whole square plus y square. Now S will be equal to x minus 18 whole square. Now we need to convert into function of single variable, so y is x square, so that will give x raised to 4. So we need to minimize S equal to x minus 18 whole square plus x raised to 4, where x belongs to the interval minus infinity to infinity. So x can be any arbitrary point, because x can take any value from minus infinity to infinity. And now minus infinity plus infinity function value infinite ആയിരിക്കും. So therefore it will have a minimum value. So minimum value will occur at the critical point. So let us find ds by dx. So that will be 2x minus 18 plus 4x cube. So ds by dx equal to 0 implies, so you will get 2 will cancel up, 2x cube plus x minus 18 equal to 0. So let us find the solutions of. Now here when you substitute x equal to 2, you can see that x equal to 2 is a solution. So x minus 2 is a factor. The x minus 2 കൊണ്ട് divide ചെയ്ത് കഴിയുമ്പോൾ the remaining polynomial you are getting as 2x square plus 4x plus 9 equal to 0. So one root will be 2, and here when you take b square minus 4ac, that will be negative. അപ്പോൾ real root ഇല്ല രണ്ടാമത്തെ polynomial. So therefore x equal to 2 is the critical point. And now let us check the second derivative also. So when you take d square s by dx square, so the derivative is going to be 12 x square plus 2. So when x equal to 2, so d square s by dx square is greater than 0. So therefore x equal to 2 is a minimum point. So therefore we have got the value of x equal to 2. So y is given by y equal to x square. So therefore the closest point is, so the closest point will be equal to 2, 4. So that is the solution. So with this we will wind up the first module. So in the next session we will begin the second module. Thank you.